Here's a definition for a parabola. It's a set of all points in a plane equidistant from a fixed line called a directrix and a fixed point not on the line called the focus. So I want you to notice that you have these two very important things. One's a line called a directrix, and the other one is a point called a focus. All right, let me give you a picture that would help us understand the definition of a parabola. So here we have a directrix, which is just a line, and a point called the focus, and the focus is not on that line. So a parabola, by definition, is a set of all points that are equidistant, meaning the same distance from the directrix as they are from the point called the focus. So a parabola would be something like this. Okay, now all of these points that are on this parabola. Now this is just a picture to help us understand the definition, okay? I just chose, for whatever reason, to draw a parabola opening to the right. But I could draw a parabola for you opening to the left, or opening up, or opening down, and it's the same argument, okay? So every point on this parabola has something in common. Let me show you what that is. So here I've called out a random point that's on my parabola, a random point, and this is the idea that the distance that the point on the parabola is from the directrix is the same distance that that point is from the focus. These two distances are the same. That is to say that these two distances, d sub 1 and d sub 2, are equal. And that's true for every point on our parabola. Every point on the parabola has that in common, that its distance, the distance from that point to the focus, is equal to the distance from that point to the directrix. Cool? Okay, so let's first talk about the standard form for a parabola whose vertex is at the origin. The vertex is at the origin, which is 0, 0, okay? And then after we're done with this conversation, we can then apply that to a parabola that has been translated or shifted in the plane. So here we have the first equation, x squared is equal to 4 times p times y. Over here, y squared is equal to 4 times p times x. Okay, let me show you what each of these equations represent. Okay, I'll tell you and then I'll draw you a picture. If x squared is if x is being squared, if the variable x is being squared, then you have a parabola opening either up or down. If it's the variable y that's being squared, then you have a parabola either opening left or to the right. So I'll say that one more time. If x is being squared, your parabola is going up or down. If y is being squared, your parabola is either going left or right. So here's a picture, or a couple pictures, to go with that standard form, with x being squared. So first of all, this parabola is the vertex for this parabola is right at the origin, and this point here is the focus, has coordinates 0, p, and this is the directrix here, having the equation y equal to negative p. Please notice that the distance from the vertex, and this is really important, the distance from the vertex to the focus is p number of units. The distance from the vertex to the focus is p. The distance from the vertex to the directrix is also p number of units, all right? I have it labeled y equal to negative p just because this line is below the x-axis, so it's negative, okay? This is the picture, guys, for whenever p is positive. If your p value right here in the equation is a positive number and x is being squared, then you know you have a parabola that is going upward. If x is being squared and p is negative, then you have a parabola opening downward. And that's what I meant right here when I wrote p less than 0. That means p is negative. So again, the vertex is at the origin. The focus is located p units away from the vertex. And then the directrix is located also p units away from the vertex. Can you notice something? The focus and the directrix are on opposite sides of the vertex. Look at the focus and the directors on opposite sides of the vertex. The focus, you guys, the focus will always be within the branches of the parabola. The focus will always be inside the parabola, if you will. Okay, now let me show you what this parabola would look like when y is being squared. When y is being squared, then you either have a parabola opening right or to the left. Okay, guys, here are the pictures. So here we go. So when y is being squared and p is positive, then you have a parabola opening to the right. When y is being squared and p is negative, you have a parabola opening to the left. Notice that the focus for each of these cases is inside or within, trapped within the parabola. Now be careful here. The equation for the directrix, now that it's vertical, is now x equal to negative p. This is p units away from the vertex. The focus is also p units away from the vertex. Over here, it's x equal to positive p because now that directrix is to the right of the y-axis. It's still p units away from the vertex. And the focus is also p units away from the vertex. The coordinates are negative p comma 0, negative p because now you're on the negative side over here for your x coordinates. All right, everybody, so this is it. So all I'm going to do now is apply what we've just studied to a parabola that has now been shifted to the left or to the right or up and down, okay? So all of this applies to transformations of our parabolas. So these are the two forms for our standard form for the equation of a parabola whose vertex is now h comma k. All right. This first one here on the left-hand side, this is the variable x being squared. So this is the standard form for the equation of a parabola opening up or down. Over here, y is being squared. So this is a standard form for a parabola that is opening to the left or to the right. I just want to throw this out there, you guys. At this point, we have studied 4 different conics. We've studied the circle, the ellipse, the hyperbola, and now the parabola. Now, with all of these standard forms, I wanted to help you out a little bit with your studying. With the circle, with the ellipse, and with the hyperbola, both of the variables are being squared. Check out the standard form. You will confirm the following, that both x and y are being squared for a circle, an ellipse, and a hyperbola. The only conic that has only one variable being squared, either x or y, but not both, is the parabola. So whenever you only have one variable being squared and that's it, you know for sure you have a parabola on your hands. All right? If it's x that's being squared, you know your parabola is going up or down. If it's y being squared, you know your parabola is going left or right. So when x is being squared and your p-value is positive, you know your parabola is going upward, yeah? If your x is being squared and p is negative, you know your parabola is going downward. If y is being squared and p is positive, then you have a parabola going to the right. And when your y variable is being squared and p is negative, your parabola is going to the left. Okay, everybody? I think we are ready for our first example. All right, here's our first example. Determine the vertex and direction of each of the following parabolas and then graph. So for the first parabola in this example, we have y squared is equal to negative x. Now, doesn't this, you guys, look awfully similar to our standard form, which is y squared is equal to 4p x, right? So a few things we know automatically. We know that the center, or not the center, excuse me, the vertex of this parabola is at the origin, right? Is at 0, 0. So this is what we know so far. We know the vertex is at the origin, and we know the direction is left, right? How do I know that? Well, y is being squared, so my options are either left or right. But because I see that this right-hand side is negative, I know my p-value will be negative, So I must be going to the left. Now, they said determine the vertex. We did that. Determine the direction. We did that. And now let's graph, okay? Now, one thing I want you to notice is that this here, 4p, must be -8, right? This is y squared, that's y squared. I have x, that's x. So then this 4p must be equivalent to -8, right? So let's figure that out really quickly. So this implies that 4p must be -8, which when you divide both sides by 4, you get that p must be -2. So this p-value is going to help you find your vertex. Excuse me, no it's not. It's going to help you find your focus, all right? All right, let's focus here, Professor Gutierrez. All right, so let's graph our parabola. Cool. The first thing I'd like us to do is to plot the vertex, which is right here at the origin of our plane, all right? And we do know that the parabola is opening to the left. Because the parabola is opening to the left, so it's doing this, right? This direction here. That means the focus has to be over here. Remember, the focus will be within the parabola, the branches of the parabola. So the focus will lie right here on the negative part of the x-axis. And it will be 2 units away from the vertex, right? Because p is -2. So 2 units to the left of the vertex, you'll find your focus. Right here, this is your focus, right? Your the coordinates for that focus, because it lies right on the x-axis, is -2, 0. All right. Now the directrix is a vertical line, right? It's a vertical line, 2 units to the right of the vertex. So then the directrix is something like this, okay, that vertical line, which has the equation, because it's a vertical line, be careful here, it has an equation of x is equal to +2, okay? All right, so I have my directrix, I have my vertex at the origin, I have my focus. Now all I really need is to draw the parabola, but I want to be careful. We have to figure out kind of like how wide opening this parabola is. I know it's going to the left, but is it like a narrow opening parabola or is it really wide? And so what's really going to help us here is a line segment called the latus rectum. That is a line segment that goes right through your focus. And the endpoints of that line segment lie right on your parabola, okay? So what we're going to do is from our focus, we're going to move up and down to find the endpoints of that latus rectum. But how many units? We're going to go up from the focus. We're going to go up 2 times the absolute value of p units upward, and then we'll hit our parabola up there, and then 2 times the absolute value of p units downward to hit the parabola down here. Here, let me write all of that down for your notes, okay? So I added this for your notes. The latus rectum is a line segment passing through the focus. So it's going to go like this, guys, up and down through your focus like that, with endpoints on the parabola. Okay, this will help us draw a parabola. Now, the endpoints will always be found by going 2 times the absolute value of p units from the focus. So let me show you how I actually figure that out. So it's 2 times the absolute value of -2, which is equal to 2 times 2. The absolute value of -2 is just 2. So 4. We're going to go 4 units up from the focus and 4 units down from the focus. Did you catch that? That's going to give us how wide opening our parabola is. When I go 4 units up from the focus, I end up at -2, +4. When I go down 4 units from the focus, I end up at -2, -4. Okay? Let me plot, or let me, I just plotted them. Let me label those points for us, okay? So, let's see. The first one is -2, +4. We found that point by going up 4 units from my focus. So that allows me to do this, like that, okay? And then the coordinates for this bottom point here turned out to be -2, right? But this time, comma, -4. And I found these coordinates by going down 4 units from the focus. So it allowed me to do something like that. Okay, so there is my final picture. So we found the vertex, we found the direction of the parabola, and we also graphed the directrix as well. And let's see, the focus, and then the latus rectum, the line segment that's going right through. I can draw you that line segment if you like. The latus rectum is doing this, folks, like that. That's the latus rectum right there. Okay, which is allowing us to get how wide opening our parabola is. Man, this is so much fun, isn't it? Okay, I hope you're having fun as I am. Okay, let's go to the next parabola, okay? Okay, guys, here's our next parabola. I know it's a parabola because there's only one variable being squared, and that is x is being squared. It's x plus 2 quantity squared is equal to 12 times y minus 1. Now, this looks awfully familiar to our standard form that looks like this. X minus h quantity squared is equal to 4p times y minus k. Right, everybody? Okay, now listen. X is being squared. So you either have a parabola opening upward or downward. But because 12, this coefficient, which represents 4p, because this is positive, we know p is positive, so that must mean our parabola is opening upward, okay? Now, we can see what our vertex is. It's -2, that's h, -2, +1. -2, +1, and our parabola is going upward. Okay, everybody, now that we have our vertex and our direction, let us find p. Now, p, 4p right here is represented by 12, right, everybody? I'm equating. This coefficient, 4p, is 12, all right? So you can divide both sides by 4 to get that p is equal to +3, okay? All right, now that p is going to give me a lot of information, okay? Let's go ahead and start graphing our parabola. Okay, everybody, I think I've scaled my axes okay. We'll find out really soon here. The first thing I want to plot, though, is my vertex, which is -2, +1. All right, there's my vertex, -2, +1. And then the directrix is, since this parabola is going upward, since this parabola is going like this, guys, going upward, I know my directrix is going to be a horizontal line down here, right? Now, the horizontal line will be the directrix, and it will be found by moving 3 units down from the vertex. 3 units down from the vertex. So 3 units down from the vertex will drop you off at -2, -2. What I'm drawing here is your directrix. Let me, I'm going to want you to label that, right? So y is equal to -2. Again, I found that by moving 3 units down from my vertex. When I move 3 units up from my vertex, I find my focus. 3 units up from the vertex will drop me off at -2, +4. About right there. Okay, that's my focus. That's my focus. That's a big F, but anyway, there's my focus, okay? It has coordinates -2, +4. Now, I'm ready to draw my parabola that's opening upward, but I need to find the 2 endpoints of my latus rectum, all right? So, do you remember that the latus rectum, let me get this prepared here. So, will be 2 times the absolute value of p, so it'll be 2 times the absolute value of 3, which would just be 6, right? So what I'm going to do is I'm going to move 6 units. Now watch this, guys. Remember the parabola is going upward, all right, everybody? It's going like this. It's going upward. That's how I knew my focus was going to be up here somewhere. And that's also how I knew that the directrix was going to be a horizontal line. Now, the lattice rectum will be a line segment that's going right through your focus. It's going right through your focus. So it's parallel to your directrix. It's going right through your focus, and it'll be 6 units to the right of the focus and 6 units to the left of your focus. 6 units to the right of your focus will drop you off at 4, 4, out there. And then 6 units to the left of your focus will drop you out at -8, +4. So you can see, like, wow, this is a really wide opening parabola. I would have never known how wide opening it is without that lattice rectum helping me. And I can draw you the lattice rectum again. It's going right through your focus, and the endpoints of that line segment are on the parabola. Cool deal, right? Here's our brand new example. Y minus 3 quantity squared is equal to 6 times x plus 2. So the first things that I notice is that y is being squared. When y is being squared, the parabola is either going to open to the left or to the right. In this case, I know it's opening to the right because this value here, which represents 4p, 4 times p, is positive. So I know it's opening to the right. Now, I also notice that my vertex, which is h comma k, remember h is always with x, and k is always with y, my vertex is -2, +3. So really what I'm interested in finding at the moment is what p is. So notice that the 6 is representative of p. Now, let me show you how I know that. This equation is of this form. Y minus k quantity squared is equal to 4p, there it is, times x minus h, right? So then I know that 6 is 4p. So I'll take 4p and set it equal to 6 and solve. When I divide both sides by 4, I get p is 6/4, which is the same thing as 3/2. Okay, so p is equal to 3/2. This p value is going to help me find a lot of information. Okay, let's go to the plane. So I have our plane here, and I plotted our vertex. So -2, +3. Now I know this parabola is going to be opening to the right, like this, opening to the right. That must mean the directrix is over here, and it is a vertical line, okay? Now the directrix will be found by moving p number of units to the left of the vertex. Now p is 1.5, 1.5, okay? So if I'm at -2, +3, -2, -2, +3, I'm at -2. If I move 1.5 units to the left, that's 1 unit and then 1/2 of a unit, that would put me at -3.5, 3. So that's what I'm going to draw. A line going right through -3.5, right there. So this has the equation x equal to, let me write it here, x equal to, let's see, -3.5. I'll write it as a decimal. I think a lot of us prefer decimals, so there it is. Okay, there's the equation for our directrix, okay? Now our focus will be found by starting with the vertex and moving 1.5 units to the right. Now, if you, again, you're at -2, 3. -2, when you move 1.5 units to the right, you end up at -1/2, right? Look at -2, 1 whole unit, and then 1/2 of a unit. That's 1.5 units to the right, leaves you at -1/2, -1/2, 3. That's your focus. About right there. I'll put coordinates next to that plotted point now. All right, I put the coordinates for the focus. So all we really need to figure out now is the endpoints of the lattice rectum, which will tell us how wide opening our parabola is. Now, do you remember that the endpoints can be found by taking 2 times the absolute value of p? So it'll be 2 times the absolute value of 3 halves. So it's just 2 times 3 halves, which is just 3. So if we started our focus and go up 3 units and go down 3 units, we will end up at the endpoints of our lattice rectum, which lie on the parabola. Now, the focus is here at -1/2, +3. If I go down 3 units, I'm right on the negative x-axis at -1/2, comma 0. So let me go ahead and plot that point. About right there, okay? And I'll label that in just a second. When I go up 3 units from -1/2, +3, I end up at -1/2, +6. Okay, about right there, okay, guys? And again, I'll label that point right now. So then our parabola is going through those 2 points there, right? Your lattice rectum is, oops, I didn't mean to do that. Your lattice rectum, hold on. Okay. Your lattice rectum is the line segment that's going right through the focus, whose endpoints are on the parabola. Okay, let me give you the coordinates for those 2 points that are the endpoints of the lattice rectum. Okay, I have everything labeled for us. So I have the endpoints of the lattice rectum with the coordinates, right? And again, one more time, I found those 2 points here on the parabola by starting at my focus and moving up and down 3 units. The way I got 3 units is by multiplying the absolute value of p by 2, which gave me 3. All right, everybody? So this is the final graph. Let's go to the next example. All right, guys, x squared plus 8y plus 8 is equal to 0. The first thing I notice, I don't know about you, the first thing I notice is which variable is being squared. X is being squared. So this parabola is going to open up or down. In order to graph it, though, I want to write this in standard form. So I think I'm going to move all of my y terms, actually the y term and the constant term, anything that doesn't have an x, basically, over to the other side. That would leave us with x squared is equal to -8y minus 8. The next thing I'll do is, you know what I can do is I can rewrite the left-hand side just to be really, really clear about what my vertex is. The left-hand side is the same thing as x minus 0 quantity squared. On the right, I want to factor out that -8, leaving me with y plus 1 inside, like that. So this matches my standard form, which is, I'll remind you, x minus h quantity squared is equal to 4p times y minus k, right? So we can see that your h value is 0, your k value is -1, and 4p is -8, right? So let's take that 4p value now. We can see 4p is equal to -8, which just means that p would have to be -2. You can divide both sides by 4 to see that. All right, so what I'm going to do is I'm going to take my standard form and my p value, and then I'm going to make kind of like a summary of what we have so far. So this is what I have, you guys. I have the vertex at 0, -1. The direction is down. Remember, my options were up or down because x was being squared. Because we found p to be -2, we know it's opening down. This is a standard form for the equation. Okay, guys, I scaled my axes. The first thing I'm going to do is plot my vertex, which is 0, -1, right there on the negative part of the y-axis. Now, my p-value is -2. Okay, that's what's telling me that my parabola is opening downward. Now, in order to find my directrix, I know my directrix will be 2 units away from my vertex. My focus will also be 2 units away from my vertex. So since this parabola is opening downward like this, I know my directrix will be up here and my focus will be down here because the focus is always inside the parabola. Okay, so then let's get this directrix. which in this case is going to be 2 units up from the vertex, which would put me here for my directrix, a horizontal line. Because it's a horizontal line, I know the equation that defines that directrix is y equal to, right? Not x equal to, but y equal to, and it's y equal to positive 1. Okay, now the focus will be found by moving 2 units down from the vertex of the parabola, which will put you at 0, -3. Now that's the focus, okay? The focus, it has coordinates 0, comma, -3. Cool. Now, I'm pretty much ready to draw my parabola, but I need to know how wide it's opening. So this is the part where we get the lattice rectum, right, everybody? So let's see if I can squeeze this work up here. 2 times the absolute value of p, so it'll be 2 times the absolute value of -2, which just turns out to be 4, positive 4. So what I'm going to do is I'm going to move 4 units from my focus to the left and to the right of my focus, to the left and to the right of my focus, 4 units, and that will give me the endpoints of the lattice rectum, which are points on the curve, the parabolic curve. So 4 units to the right of the focus would put me at 4, -3, about right there, okay? 4 units to the left will put me at -4, -3. And so the lattice rectum looks like this, like that, and my parabola can be drawn now like this. I know how wide it's opening, okay? Let me give you the coordinates for those 2 points we found. All right, you guys, there's the graph of our parabola opening downward with the directrix and the lattice rectum even drawn, and the endpoints of the lattice rectum, the focus, the vertex. It's all there for us. Pretty cool, no? All right, next example. Brand new example. Graph the parabola 2y squared minus 16x minus 8y plus 40 equal to 0. Of course, labeling the vertex, focus, directrix, and the endpoints of the lattice rectum, what we've been doing. Okay, now, which variable is being squared? The variable y is being squared. That means your options are the parabola will open to the left or the parabola will open to the right. In order to figure out which is the correct direction, let us rewrite this equation in standard form. This will require completing the square in y. All right, in order to get that started, I am going to collect my y terms together, and I will move everything over to the other side. There. I'm collecting my y terms together. I move the other 2 terms to the other side. In order to complete the square in y, I need to make the leading coefficient 1. So let's factor out a 2. Okay. Alrighty. Now, let's complete the square. And now we've done this a few times now. I'm going to take half of -4, which is -2, and square -2, which gives you positive 4. So the number that I'm adding is positive 4 right here. Okay, now, whatever you added to the left, you must add to the right. Now, you added much more than just 4. You've added 2 times 4. You've added 8 to the left-hand side, so we must add 8 to the right-hand side. So the left-hand side now is 2 times y minus 2 quantity squared is equal to 16x minus 32. Cool? Now, in order to put this in standard form, let's divide both sides by 2. Okay, so let's divide the left-hand side by 2 and the right-hand side by 2. Everybody by 2. That'll give us what? Let me move the screen up a little bit. That'll give us y minus 2 quantity squared is equal to 8x minus 16, which will give us the standard form y minus 2 quantity squared, factor out the 8, times x minus 2. This is standard form for the equation of this parabola that they gave us. So now you can see that 8, which represents 4 times p, is positive. So this parabola, which we said in the beginning, because the variable y is being squared, the parabola is opening to the left or to the right. But now that we see a positive 8 right here, we know our p-value is also positive, which means this parabola is moving, or not moving, but opening to the right. Now what I would love to do is to find p, all right? So we know that 4p is equal to 8, which just tells us that p is equal to positive 2. Now that p-value of positive 2 is going to help me find my focus, it's going to help me find my directrix, it's also going to help me find the endpoints of the lattice rectum. Actually, let's put that aside, p is equal to 2, and let's also do this while we're here. 2 times the absolute value of p, which would be just 2 times the absolute value of 2, which is just 4. Now this is, remember, the distance that we're going to move from my focus in order to find the endpoints of the lattice rectum. All right, let's show a picture of what we have so far. Okay, guys, I'm going to plot my vertex. My vertex is 2, 2. My directrix will be found by moving p number of units to the left of the vertex. When you move 2 units, because p is 2, when you move 2 units to the left of your vertex, you end up right on top of the y-axis, right? So, of course, the equation that defines the y-axis is just x equal to 0. Very good. All right, so we have our directrix, we have our vertex. Let's get our focus. Our focus is found by moving p number of units, which is 2 units, to the right of our vertex. So it'll be 4, 2. Okay, those 4, 2 is the ordered pair for our focus. Let me plot that for us, or give the coordinates for us. 4, 2. All right, cool. So what do we have? We have our vertex, we have our directrix, we have our focus. Now what's cool is we already did this work. 2 times the absolute value of p, which turned out to be 4. Remember, this is how many units I'm moving up and down through my focus in order to find the endpoints of the lattice rectum. All right, when you move 4 units up from the focus, you end up at 4, 6. When you move 4 units down, you end up at 4, -2. So let me plot those. 4 units up would be 4, 6, about right there. And 4 units down would be 4, -2, about right there. Let me give coordinates to those 2 points. All right, cool. So now we can finish off our parabola because we know how wide it's opening. So there's our parabola with the vertex clearly labeled here at 2, 2. I even wrote it up here, 2, 2. We do know the directrix is x equal to 0. We know 2 points that are the endpoints of the lattice rectum. The lattice rectum, if you'd like me to draw it, looks like that. And we have our focus as well. All right, you guys, this is going great. Let's go to the next example. Okay, guys. Example 4 and example 5, the last 2 examples of the section, will not ask us to graph the parabola. They just want us to find the standard form of the equation of this parabola. Now, in order to find this standard form, I do want us to take just a few seconds to draw a really rough sketch of what they've given us, and then we can figure out the direction of the parabola and things like that, okay? Now, they said that this parabola has vertex 3, -1, 3, -1, and a focus of 0, -1. So 3, -1, 1, 2, 3, -1. Okay, I'm doing this fast on purpose so that you can see I'm not trying to be super perfect here. That's my vertex, 3, -1. And then they said it has a focus of 0, -1. Okay, guys, this is your focus. Now, that's all I'm going to do, okay? Now, this is what I want as far as the graph is concerned. I want you to think about the direction of this parabola. Is this parabola opening up, opening down, opening to the left, or to the right? Well, it could not be opening up because the focus has to be within the parabola. So that doesn't make sense. It cannot open down for the same reason. It cannot open right for the same reason. So the only option is for this parabola to be opening to the left like this. So just doing a super rough sketch of what they've given us, we do know the direction of this parabola is opening left. If it's opening left, I know that it's the variable y that has to be squared. I also know that my p-value has to be negative. So this is what we have, guys. This is the standard form for the equation of this parabola. Now, can I erase a little bit of this parabola just to make a little room here? So notice that I might have erased a little too much of the parabola, that number 3 there. Notice that we know what the vertex of this parabola is. It's 3, -1. Be careful here, guys. The 3 is your h value, and your -1 is your k value. So then it's y minus -1 quantity squared is equal to 4 times p times x minus 3. That's what you and I have. Now, you know that this turns out to be y plus 1, right? Quantity squared. But I wanted to talk to you about your p-value. Remember, p is the distance that you are moving from your vertex to get to your focus. But you can see here, I hope that you can see that this distance here, which is p, is 3 units. This is 3 units. So p, that tells you that p is equal to -3. Why did I say -3? Well, because this parabola is opening to the left. And whenever p is negative, that's what makes your parabola open to the left. If this parabola were opening to the right, I would have put p is equal to +3. So with that being said, I can finish off the standard form for this equation by plugging in -3 in for p. All right, so I have y plus 1 quantity squared is equal to 4 times -3 times x minus 3. Okay, so then that is going to give us, if I can just erase some more here, that's going to give us a standard form of, okay, good. We got y plus 1 quantity squared is equal to -12 times x minus 3. This is the standard form for the parabola that they were describing earlier. Isn't that great, you guys? We just sketched a quick picture and we figured it out from there. Cool, let's do one more like this. I think these are a lot of fun. All right, you guys, last example. Find the standard form of the equation of the parabola that has directrix y equal to -5 and focus at -2, -1. Okay, you know what I'm going to recommend. I want us to draw a picture of what's going on. Okay, so let's do this. All right, let's do this. So 1, 2, 3, 4, -5. And I'm trying to go fast on the graphing part of this because I want to emphasize that this is just a rough sketch, okay? I want to emphasize that I'm not trying to be super neat because they never said to graph the parabola. They just said find the equation. So the point of this rough sketch is just to give me an idea of what's going on here. The focus is at -2, -1. So it's like that. So with this being said, what are your options? And this is your focus, everybody. So what are your options? Well, could your parabola be opening, could it be opening to the right like that? Could it be doing that? I hope your answer is no, absolutely not. The parabola never intersects its directrix like that. So that can't happen. The same reason it cannot be like this, right? Because then it would cross your directrix right there, which is bad. That never happens. So opening to the left or to the right is not an option. How about opening down? No, again, it's going to intersect your directrix. That's bad. So the only way this makes sense is if the parabola is opening upward. So we have a parabola opening upward, ladies and gentlemen, opening upward. Cool. Now, if it's opening up, we know a few things. We know x is being squared, and we know p has to be positive. Okay? All right, you guys, this is kind of like a summary of what we have. I know the parabola has to be opening upward. That must mean x is being squared, so I know this is the form of my standard form. And I know p must be positive in order for my parabola to be going upward. Now, let's talk about this vertex. Where is the vertex going to be located? The vertex will be located right in between the focus and the directrix. Now, if you recall at the very beginning of this section, we said that a parabola is defined to be a set of all points that are equidistant. That means the same distance from a fixed point called a focus and a fixed line called a directrix. In other words, since the vertex of the parabola is a point on the parabola, the vertex has to be the same distance from the focus as it is to the directrix. In other words, the vertex has to be right in the middle of the focus and the directrix. So the vertex has to be right here. Now, if it's right in the middle, then what are the coordinates? Well, when you're right in the middle here, you're already at -2, right? This is the x-coordinate of the focus, which is the x-coordinate of the vertex. So let me see if I can label this on the x-axis, -2. So the vertex is at -2, and then, here we go. If this is -1, right? And if this is -5, okay? -1 to -5, what is right in the middle between -1 and -5? -3, that's right. -3 would be right in the middle between the y-coordinate of -1 and the y-coordinate of -5. Okay? You can also determine this. Between the directrix and the focus is 4 units. In order to go from the focus down to the directrix, that's 4 units altogether. That must mean that right in the middle would be 2 units. So this tells me right now that P must be equal to 2. Okay? All right, and it's positive 2 because this parabola is going upward. So it's doing this, right? See? This now the distance from the vertex of the focus is 2 units. The distance from the vertex to directrix, the vertex to the directrix, that's too many x's, is also 2 units. Okay? All right, so let's plug everything in. So now we have x minus you know what I should do for us is label the coordinates for your vertex. I think I said it out loud, but I don't think I actually wrote it. So let's do that. -2, comma, -3. Okay? All right. There we go. Okay, so then your h value is -2. So it's x minus -2 quantity squared is equal to 4 times p, which we figured out to be 2, times y minus -3. All right, so then x plus 2 quantity squared is equal to 8 times y plus 3. This must be the standard form for the parabola that they were describing.